Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. How are you guys? I hope you are good enough to join this lecture. And I hope you have had your breakfast to fuel up your morning. Waalaikumsalam Ali. Hi Nurin. Good morning Gan. Waalaikumsalam. Who is Tialia? Good morning Mac. Waalaikumsalam Syamsul. Sam. Waalaikumsalam Aisyah. Good morning Aisyah. Good morning Amanda. Good morning Liu. Good morning Azaril. Good morning Kai. Razif. Izazi. Amira. So today we are going to continue discussing topic 8. Alright, and our objective today is to finish all the learning outcomes that we didn't manage to accomplish last Tuesday or yesterday or last Wednesday. Good morning Zahid. So alright, so let's see the list of learning outcomes. Alright, so last Wednesday we discussed the A, B and C. Not only that, we also discuss the D, learning outcome, find the probabilities of the intersections and unions of the events. Today we are going to discuss these two learning outcomes. We are going to find conditional probability and identify independent events. So in order to accomplish this, we are going to use contingency table or table of outcomes. And there is also a remark here. So in this topic, we will exclude the Bayes theorem. Because it is out of your syllabus. And the last learning outcome, we are going to use Venn diagrams, tree diagrams, and table of outcomes. Again, table of outcomes is basically a contingency table. So to solve probability problems. So now let's see the content that we will be discussing today. So let's go through the summary a bit. So summary, this is basically summary of topic 8 that I have given you. So I hope that you can make full use of this summary to help you with revision, to help you with self-study, and to help you understanding this topic better. So that you will be able to grab the concept of topic 8, probability, and thus you'll be able to tackle any questions given. So as what we discussed last time, we discussed all the terms, all the important terms, in this topic, and also the basic law. So let's recall. So the first law of probability. So we know that for any event, the probability value must be from 0 to 1, where 0, if the probability is 0, we call that event as impossible event. It will never happen. While if the probability of the event is 1, so we can say that the event is an absolute event. So we are confident enough that the event will happen. And then not only that, the second law of probability, so the sum of probabilities of all possible outcomes is 1. So if we total up the sum, we should get 1. And then the complement rule. So complement rule, so we are going to use the bar this is prime notation, or we can also use the bar. So A prime or A bar is called as complement event of A. And then we also discussed the addition rule. So whereby if you have probability of A union B, it is equal to probability of A plus probability of B minus probability of A intersect B, and this can be proven using the Venn diagram. And then so this is what we are going to discuss today, the conditional probability. So now let's see what we are going to discuss today. Alright, so conditional events. What are conditional events? Alright, when an event happens, is considered with the condition that another event has occurred, then the event is conditional event. For example, the event that a girl is chosen knowing that the student wears spectacles. So now, we know this. So this is the keyword, knowing that. So we know that the event at the back has already happened. So this event has already happened. Okay, so in this case, we know that the student wears spectacles. Okay, so what is the probability that the student is a girl? Okay, so whenever we have this kind of situation, so this is what we call as conditional event. Okay, so and the second example, two balls are taken from a box containing several red and blue balls without replacement. Okay, so without replacement means after we have taken one ball, then if you don't put it back, so we can say that the number of balls are going to reduce. Alright, so that is conditional event also. Okay, because the event of getting second ball depends on the event of getting the first ball. Okay, because we know after we have taken one ball, the first one we don't replace it back, so which means the number will be reduced. And for this conditional probability, we do have formula. Okay, so again, conditional probability is the probability that an event will occur given that another event has already occurred. Okay, so the definition. So let's say here, if we have two events, A and B in a sample space as, okay, so we define the conditional probability of A given B by this. Okay, so this is the formula that you need to pay attention to. Okay, and here probability of A given B, so that is how to, so this is how to read, okay, how to read this symbol, probability of A given B. Okay, so the probability of A given B is equal to probability of A intersect B divided by probability of B. And the same thing if, okay, and you need to know that, okay, whatever event we have at the back, which means the event has already happened. Okay, the event that we put at the back has already happened. So if we try to change the formula, let's say if you have the event A that has already happened, so we can change the formula. So let's say how to find probability of B given that A has happened. So you can simply change the formula. So you will have the formula to be B intersect A divided by PA. Okay, so you have to bear in mind, okay, the probability, the value of probability in the denominator is related to, okay, the probability of the event that has already happened. So in this case, since the event A here has already happened, okay, so has happened, so which means the value in the denominator will be, okay, the probability of event A. Alright, okay, so now let's see an example. Okay, so example 1, the question is quite straightforward, okay, whereby, okay, we do have the values. All right, okay, so now the events A and B are such that probability of A is given 1 over 4, probability of B is 1 over 3, and probability of A union B is given 5 over 12. Okay, now the question says find probability of A intersect B. Okay, and if we recall, we do have additional probability formula, right? So in order to find this, so we are going to use additional probability formula. Okay, so this is additional probability formula. Okay, so where the formula is probability of A union B equals probability of A plus probability of B minus probability of A intersect B. Okay, so now we are given these three. So we just need to find probability of A intersect B, right? So we just rearrange so that probability of A intersect B will be the subject. Thus, we will get the value here. Okay, 1 over 6. And now how to solve the second question here? Okay, so find the probability of B given that A has happened. Okay, so by using the formula, so probability of B given that A has happened is equal to probability of B intersect A divided by probability of A. Okay, so again, you see the event that has happened will be in the denominator. So in this case, A has happened. Okay, and the event at the back is the event that has already happened. So now we just need to find the probability of B happening. Okay, so now because we already have this, and for your information, probability of B intersect A is simply equal to probability of A intersect B. Because when we talk about the region in the Venn diagram, so we are talking about exactly the same region here. So this is A and B. Okay, so this region is basically the region of A intersect B or B intersect A. Okay, so it just represent the same region. Okay, so you don't really have to worry. So when you need to work, okay, you work on the probability of B intersect A, so we can just get our previous answer and we bring it here. Okay, so the formula is probability of B intersect A divided of probability of A. So we have got the probability of A given 1 over 4. So we just write it down and then we just press calculator. So this is the answer. Okay. Alright, so now this is first example. Okay, the question here is very straightforward. Okay, what about example 2? Okay, A and B are two events such that probability of A is given, probability of B is already given, and probability of A union B is given. So find probability of A intersect B. So again, we are going to apply the addition probability formula. So this is the addition probability formula. So again, okay, you may notice that in this topic, we will be applying this addition probability formula quite a lot. Okay, so you have to know this formula, but you don't really have to memorize it, okay, because the formula will be given in exam, so no worries. Okay, so probability of A union B equals probability of A plus probability of B minus probability of A intersect B. So now we are provided with these three values. We have here, we have this, and we have this. So again, we just rearrange and we make the probability of A intersect B to be the subject, and we will get the answer. Okay, now coming to the second question, how to solve this? Okay, how to solve this question? Okay, A intersect B prime. So, okay, if you may recall, okay, so what is A intersect B prime? So again, if we draw a Venn diagram, okay, so you have this A and this is B, right? Okay, so A intersect B prime. So A is this. Okay, intersect with B prime. B prime is anything except for B, right? Anything except for B. Okay, so if you shade the region, okay, so you may notice that, okay, the intersection between the red and the green color is actually this region. The intersection between red and green is actually this region. And okay, how can we obtain the region? So we are going to apply the other formula. So this is the other formula that we already discussed, yeah, in previous lecture. Okay, so we can obtain the probability of A intersect B prime by having probability of A minus probability of A intersect B. Okay, so the whole circle of A here, we subtract with this region. Okay, because we know the region here is A intersect B, right? So PA minus PA intersect B. Okay, so because we already have the PA and the intersect, okay, PA intersect B has already been obtained in previous example, okay, in previous part. So we can substitute the value and we will get the answer here. Okay, so we are done with, okay, the B part. Okay, now how to solve the C part. Okay, this is conditional probability, yeah. So this is conditional probability. Okay, so how can we find the value? So again, we do have formula. If you have P, B given A, so the formula will be, okay, PB intersect A over PA. So again, okay, I need to remind you the event that has already happened here will be in the denominator. Okay, so now because, okay, we have obtained the A intersect B, okay, probability of A intersect B, so we can just put it here because again, okay, probability of A intersect B is simply equal to probability of B intersect A. Because why? Because they actually give you exactly the same region. Okay, when we draw the Venn diagram, you will notice that both here, okay, will give you the same region. Okay, so we have probability of A intercept B from the previous solution just now. So we bring the value down 1 over 12. Okay, and then probability of A is already given in the question. So 1 over 3. We just bring it down. So we will have the answer to be, okay, 1 over 4. Okay, and then, okay, for the D part, okay, so how to solve the D part? Probability of A given B prime. Okay, so we know that B prime is what? B prime is complement event of B. Okay, so first thing first, we are going to apply the conditional probability as well. So this is conditional probability. Okay, we apply the formula. So probability of A given B prime is equal to probability of A given intersect B prime divided by PB prime. Again, because the event that has happened will be in the denominator. Okay, so now, okay, how to obtain this? A intersect B prime. So you may notice that this has been Okay, this has been obtained in the B part here, A intersect B prime. So we just bring the value down, 1 over 4. And then what is PB prime? Okay, so in this case, we are going to apply the complement rule because, okay, we know that B prime is complement of B, right? So this is 1 minus PB. Okay, because PB is given as 1 over 4. So PB prime is 1 minus 1 over 4, which is 3 over 4. Okay, so we just get this and we substitute the value inside, then we will get the answer. Alright, okay, so that is how to obtain conditional probability. Okay, and then lastly, okay, find the probability that exactly one of A or B will occur. Either one, okay, exactly one of A or B. It cannot be both, huh? So how can we do this? Okay, so if we draw a Venn diagram, okay, exactly one. So it's either A or B. It cannot be both. So it's either A, so it's either this, it's either the red region here, or, okay, I use different color, or this. Okay, because this one, okay, the red region here means A only happens. Okay, and for the green one, B only happens. Okay, so because the question says only one, exactly one, A or B will occur. So it's about the red region or the green region. So the red region here is denoted by this, A intersect B prime, while the green region here is denoted by B intersect A prime. Okay, so in this case, okay, because we have obtained the value earlier, A intersect B prime. Okay, so this is the answer for the red region, 1 over 4. So we have got the value, so we just bring it down. Okay, and next we just work on the probability of B intersect A prime. Okay, so because in order to obtain this, so actually we apply the other formula. From where? Okay, so if you refer the summary, okay, so if you refer the summary that I've given you, so this is where the other formula is located, yeah, this one. So this is what it meant by other formula. So whenever I write down other formula, so it is about this formula lah. So this is the other formula. Okay, and yeah, actually this can be proven using the Venn diagram. Okay, all right, so that is how we find it. Okay, so probability of B intersect A prime will be probability of B minus probability of A intersect B. So we just substitute the values and this is the answer. Okay, all right, okay, so that is how we find conditional probability. Okay, and let's see next example. Okay, in a college, 12% of the students are left-handed. Okay, so in this case, we declare, okay, the left-handed event to be L. So because we are given in percentage, so 12%, so 12 divided by 100 is 0.12, right? Okay, so that's why you may find here, so PL equals 0.12. Okay, and then next, 15% of the students are curly head. Curly head. Okay, so in this case, we declare the curly head student or the event of getting curly head student as C. So 15%, if you convert to decimal, 15 divided by 100 will give you 0.15. So this is how we obtain the probability value. Probability of C equals 0.15. Okay, and then next, okay, we do have 3% are both left-handed and curly head. So the keyword here is and. So which means, okay, both events happen at the same time. So this 3% or the probability is 0.03 is actually the intersection between L and C. Okay, so now we are given all these three values. Okay, so how to answer the question? Okay, let's see the A part. Given that, okay, now you see the keyword here, given that. So whenever you come across this word, given that, we know that the event has already happened. Okay, because we are sure enough that the student is curly hat. So given that the student is curly hat, okay, so we know that this event has already happened. Okay, has happened, yeah. The event has happened. So we know for sure that the student is curly hat. So what is the probability that the student is left-handed? Okay. So what is the probability that the student is left-handed? So now the question is asking for probability of L given C. Okay. So how to pronounce this? So this is probability of L given C. Why? Because we know that the student is curly hat. So what is the probability that the student is left-handed? Okay, so again, the event that has happened will be put at the back. Okay, because we know that this curly hat student, okay, has already happened. So we put the letter C at the back. So we are looking for probability of L given C. So by using formula, probability of L given C is equal to probability of L intersect C divided by probability of C. So since now we can obtain the values directly from the question, right? So this is it. Okay, this is probability of C and this is probability of L intersect C. We just substitute the values into the formula and thus this is the answer. Okay, now coming to the next question. Okay, what is the probability that a left-handed student also curly hair? Curly hat. Okay. In this question, we don't have any word like this one given that. Okay, but if you read this question again, you will notice that, okay, in this case, yeah, as I said before, right, this topic we play around with words. Okay, so it's very important that you really understand the question before you can start answering the question. Okay, so now the question says, what is the probability that a left-handed student also curly hat? So in this case, we know that the student is left-handed. So that means if we already know that the student is left-handed, so this is the event that has happened. Okay, so what is the probability that the left-handed student also curly hat? So now we are looking for the probability that the student is curly hat given that, okay, the student is left-handed. Yeah, so we are looking for probability of C given L. Okay, because in this case, we know that the student is left-handed, so which means the event of L has already happened. So we are looking for probability of C given that L has happened. So, okay, by using the formula, so we can obtain the probability of C given L to be probability of C intersect L divided by probability of L. So which we also have the both values. So we just substitute both values into the formula, and this is the answer that we have. Okay, so again, this topic, okay, it's about how you understand the question. Yeah. Okay, so whenever you are given the question, so make sure you read, okay, very carefully, try to understand what, okay, what the actually, okay, what is actually the requirement of the question, and you may start answering the question. Okay, now let's see example 4. Okay, 30 mathematics professors out of 100. Okay, so we know that there are 100 professors. Okay, so okay, the mathematics now, the mathematics professor, okay, there's nothing to do with the event. Okay, because why? Okay, first, the professors, okay, were found to be overweight. So this is the event here, overweight. Okay, so we know that 30 out of 100. Okay, so we know that NW is equal to 30. Okay, or we can say that probability of W is equal to 30 over 100, because we know that 100 is actually the number of sample space, right? Sample space elements. Okay, so 30 out of 100 were found to be overweight. Okay, then next, 10 of them. 10 of them means 10 of the overweight. Yeah, so 10 of the overweight had high blood pressure. So out of these 30, okay, out of the 30 overweight professors, 10 of them had high blood pressure. Okay, so which means 10 is actually the, okay, so 10 is actually the end of H intersect W, because okay, we know that these 10, okay, these 10 professors, they are not only, okay, they are not only having blood pressure, high blood pressure, they are also overweight. So that is how we interpret it. Okay, and then only 4 of the professors who were not overweight had high blood pressure. Okay, then how do we, okay, interpret this? Only 4 of the professors who were not overweight. Okay, not overweight means we are going to use W prime, yeah, W prime, okay, because not overweight, W prime. Okay, 4 of the professors not overweight had high blood pressure. Okay, not overweight and still high blood pressure, so H. So we know that, okay, 4 professors. Okay, so then in this case, we are going to use contingency table. So this is what we call as table of outcomes. We are going to use this method. Okay, in this case, it's quite difficult to use Venn diagram. So we are going to use table of outcomes, okay, to actually um, try to identify the, okay, try to understand the situation and put all the values, okay, in the table before we start answering them. Okay, so now we put the events here. W representing overweight, okay, overweight event, while W prime representing not overweight, okay, which is the complement event, and then H here representing high blood pressure, high BP, and then this one H prime means low BP, okay, or the complement event, not high BP. Okay, so I will just put low BP, okay, low blood pressure. Okay, so now how do we put in all the values? Okay, because we know that, okay, there are altogether 100, right, 100 professors, so that's why we put 100 here. Okay, and then, okay, 30 of them are found to be overweight. So here we see the W, right? So we put 30 here. Okay, 30 are overweight, regardless of whether they have high blood pressure or not. So, but we know that 30 out of 100 are overweight. So we put 30 here. And then 10 of those who are overweight had high blood pressure. So out of these 30, 10 of them had high blood pressure. So we put here lah, okay, because this is for the event of high blood pressure. So out of 30 who are overweight, okay, so 10 of them have high blood pressure. Okay, then only 4 professors who were not overweight, okay, only professors who are not overweight, okay, not overweight means W prime, okay, had high blood pressure. So this is the intersection of W prime and H. Okay, so then find the probability. So how do we solve this? Okay, first thing first, we substitute all the information given. So now, how do we complete the table? Okay, so in this case, based on the question, this is what we have. Okay, so this is the information that we have at the moment. Okay, now how to complete the table? Okay, now you see, okay, out of 100, we have 30 overweight, right? So for sure, okay, the rest will not be overweight. Okay, 70, okay, because out of 30, out of 100, if 30 overweight, then we know 70 are not overweight. Okay, then, okay, out of 30 as well, 10 who have high blood pressure. So we know for sure there are 20 of them who are overweight but not having high blood pressure. Okay, then out of 70 here, 4 have high blood pressure. So 70 minus 4 will give you 66. Okay, now if you total up, so 10 plus 4 here will give you 14. And 20 plus 66 will give you 86. So if you try to sum this one, okay, if you try to sum the 14 and 86, you will get 100 as well. Okay, so that is how we complete the table. Okay, so now after the table is complete, okay, now how to solve the question? Okay, find the probability that a maths professor, okay, will not have high blood pressure, okay, will not have high blood pressure if he is not overweight. Okay, if he is not overweight, which means we know that, okay, if he is not overweight means this is event that has already happened, has happened. Okay, so if he is not overweight, so which means this is the event that has already happened. Okay, not overweight means W prime. So given W prime, so what is the probability that the professor will not have high blood pressure? So again, the event is, okay, denoted by H prime, right? So we are looking for probability of H prime given W prime. So in order to find this conditional probability, we are going to apply the formula. So it's going to be probability of H prime intersect W prime divided by probability of W prime. Okay, so now where can we find the value? So H prime intersect W prime. H prime intersect W prime. So you can see the intersection is here, right? So it's 66 over 100. Okay, divided by probability of W prime. So you look for the W prime here. So you can see that the W prime is 70 over 100. Okay, so 66 over 100 divided by 70 over 100 is equal to 66 over 70, which is equal to 33 divided by 35. Okay, so do we have any questions so far? So I hope if you do have, okay, so you can simply ask in the live chat, yeah? Alright. Okay, so now let's continue. Okay, independent events. Okay, just now we discussed about conditional events. Okay, now independent events. Okay, so please listen carefully. Okay, from the probability rule for conditional events. Okay, so this is the formula that we had just now, right? If you have conditional probability, which means, okay, how to find probability of A given that B has happened. So the formula is this, probability of A intersect B divided by probability of B. So if you cross multiply, so okay, and by writing the A intersect B as a subject, so we will have probability of A given B multiplied by PB. So this is what we will get. Okay, definition. So please listen carefully. Definition. If A and B are independent events, it means that the outcome of one event does not affect the outcome of the other. Then, okay, so please listen carefully. If A and B are independent, so which means here, even though the event B has happened, okay, because we discussed just now, right, the event at the back has already happened. Okay, so even though the B has already happened, because they are independent events, so we can say that probability of A given B is simply probability of A, because the B here, okay, it will not have an effect, okay, because they are independent. So the B, okay, even though we have the B that has already happened, it will not affect the A event. So which means probability of A given B is equal to probability of A. And also, if you have probability of B given A, so here you see A has already happened, but because they are independent, so the event that has happened here, A, will not have an effect on B. So probability of B given A will be simply PB. Okay, so if we have different letters, okay, let's say I have two more different events. Okay, let's say if C and D, okay, here I let C and D to be two events. Okay, if C and D are independent, okay, if C and D are independent, so okay, so if C and D are independent, so probability of C given D is simply equal to PC. Because why? The D at the back here, it will not have an effect on the C. And same thing also, probability of D given C, okay, will be equal to probability of D, because C here, it does not have an effect. Okay, so whatever event that has happened at the back, okay, it will not, okay, it will not affect the event here. Okay, so that's why PC given D is equal to PC, and probability of D given C is simply equal to probability of D. Okay, that is the definition of independent events. So, okay, if we have this probability of A given B equals to PA, so okay, by referring back to this formula just now, okay, this is from conditional probability, right? Okay, so if they are independent, so we can change this. We can change this PA given B to be PA. Okay, so again, if independent events, okay, if A and B are independent, so which means we can say that probability of A intersect B will be PA times PB. If they are independent, if they are not, it means the two values will not be the same. Okay, so the same thing here. So if A and B are independent events, then A and B prime, A prime and B, and A prime and B prime are independent events too. Okay, so for example, if you have A and B to be independent, so the same thing apply to A prime and also B prime. So probability of A prime intersect B prime is equal to probability of A prime multiplied by probability of B prime. Okay, so the same thing here. If C and D are independent, so probability of C intersect D is equal to probability of C, okay, multiplied by probability of D, and probability of C prime intersect D equals probability of C prime multiplied by probability of D, and probability of C intersect D prime is equal to probability of C multiplied by probability of D prime, and lastly probability of C prime intersect D prime is equal to probability of C prime multiplied by probability of D prime. Okay, so you just look for the event here. Okay, and the right hand side will follow through. If you have C and D here, so you will have C and D here. Okay, if you have C prime intersect D, so you will have C prime here multiplied by probability of D, and here C intersect D prime, so you have C here and D prime, and C prime intersect D prime, so we have probability of C prime multiplied by probability of D prime. Okay. We have one question here, which is a very good one. Let's see. Okay, Fir asks here, Madam, kalau only one of the two event is independent. Okay, when we talk about independent, it has to be between two because, okay, apa maksud independent event ni? Saling, dia tak bergantung. Bermaksud, okay, when A is not independent on B, sorry, if A is independent, which means, okay, if A is not dependent on B, we can say straight, okay, we can say directly that B will not be dependent on A. Dia mutual dependent. I mean, if A is not dependent on B, so dia secara tak langsung B will not be also dependent on A. Dia memang dia mutually the independence ni, okay, it will be based on the two events. Dia tak boleh salah satu je yang not dependent. Okay, so kalau A is independent, for sure B will also be independent. Okay, so I hope it explains lah. Okay, so Fir dah respond ke situ. Oh, okay, so I hope it explains. Okay, yes Kai, Madam, ini memang untuk independent je. Yes, formula ini hanya terpakai sekiranya event itu adalah independent. Sekiranya event itu tidak independent, bermaksud kita akan masih lagi guna formula yang atas. Sebab dia asalnya dia datang daripada yang atas ni ya. Okay, dia datang daripada yang atas ni. Ini ya. Okay, hold on saya highlight sekejap. Dia datang daripada atas. Dari mana dia wujud? Dia datang daripada sini. Asalnya dia datang daripada conditional probability. Okay, asalnya dia datang daripada conditional probability formula. Okay, first we cross multiply lah. So this is the formula asalnya. This is formula asal. Okay, original formula. Okay. So, okay, if sekiranya dia independent, baru kita boleh tukar yang ini. Sekiranya dia ada independent. Okay, tapi sekiranya tidak, so bermaksud kita masih lagi stick pada formula asal lah. Okay, so maksudnya sekiranya the events are not independent, so if A and B are not independent, so kita boleh swap the statement lah. Okay, so sekiranya A and B are not independent, so what can we deduce is probability of A intersect B, okay, will not be equal to probability of A multiplied by probability of C. Okay, and also the same thing, okay, you can use the prime as well. A prime intersect B is not equal to probability of A prime multiplied by probability of, sorry, this should be B, B. So this one also probability of B. Okay, even though if you put the prime here at B as well, so A intersect B prime, so it's not equal to probability of A multiplied by probability of B prime. And lastly, okay, if you have prime at both, okay, this will not be equal to probability of A prime multiplied by probability of B prime. Okay, alright. So, okay, let's see here. Okay. Ya, alright. Okay, Kai dah respon. Okay, faham. Okay, Akil, madam, soalan ada state ke independent ke tak? Okay, soalan tu dia akan bagi tahu. Yes. Contoh kalau dia kata given A and B are independent, so that's why we can, okay, that is where we can conclude probability of A intersect B equal to probability of A multiplied by probability of B. Kalau dia tak declare, kita tak boleh simply nyatakan. Okay, Zilong, madam, adakah probability of A given B equal to probability of B given A? Tidak. Kenapa tidak? Okay, so let's compare the formula. Okay, soalan Zilong tadi, okay, adakah probability of, okay, this is the question. Okay, which is a very good one as well. Okay, good question. Okay, soalannya adakah ini sama dengan ini? Okay, now let's compare in terms of formula. Kalau kita berbalik kepada conditional probability formula tadi, probability of B given A is equal to probability of B intersect A over PA, right? Okay, kita ambil yang dah berlaku kat belakang, so dia akan turun bawah. Okay, now kita tengok pula formula yang ini. Okay, probability of A given B is when A intersect B divided by P, B kan? Okay, because the B here has happened. So kita letak yang dah berlaku kat bawah. So now, okay, in terms of numerator, yeah, they are equal. Sebab apa? Sebab tadi saya kata A intersect B sama je dengan B intersect A. Okay, this one is correct. But in terms of the denominator, if you compare, so this is PA, this is PB, so they are not equal lah. Okay, why? Because kalau PA sama dengan PB, which means there are two equal events lah. Okay, maksudnya tak ada there's no difference between A and B lah. Okay, so logically, okay, or conceptually, okay, the PA will not be equal to PB because A and B are two different events. Okay, so in this case, PA will not be equal to PB, thus this will not be equal to each other. So to answer Zilong's question, okay, PA given B equal to PB given A, the answer is no, they are not equal to each other. Okay, okay, so Sam pun ada tanya macam mana kita nak tahu event tu perlu guna independent atau tak. Ada keyword dia, ya, keyword dia adalah perkataan independent tu sendiri. Soalan tu ada nyatakan. Okay, so we don't really have to worry lah. Okay, if you go through PSPM question, okay, ada contoh soalan yang dia akan nyatakan, okay, bahawa the events are independent. So that is why. Okay, that is where we know and we are going to apply the formula. Okay, Zilong, no problem. Okay, so again, if you have any question, then you can simply write, okay, in the live chat, yeah. Okay, so now let's see here. Okay, let's see example 1. Okay, if the two events are independent, it will be declared in the question, so you don't really have to worry. Okay, or sometimes the question will ask, A and B independent, so your job is to determine whether they are independent or not. Okay, so if the two events are independent, so straightforward from here we know that, okay, we can say that PA intersect B is equal to PA times PB. Because, okay, because this formula is only applicable to independent events. Okay, again, I repeat, this formula is only applicable to independent events. Okay. Okay, so because it's now given that A and B are independent, so we can apply this. So, okay, in order to find A intersect B, okay, so we have this formula. Okay, we apply this formula, PA intersect B equals PA times PB. So we have got the two values, we just multiply them, so we will have this answer. Okay, and now next, okay, find PA union B. So how to find A union B? Again, we are going to apply additional probability formula. Again, yeah, additional, okay, probability formula. Okay, so the formula is probability of A plus probability of B minus probability of A intersect B. Okay, because we have obtained earlier, okay, because they are now independent, so we can say that probability of A intersect B is equal to probability of A times probability of B, right? So we have got this 0.1, so you may just replace here, or if you want to bring down again the value, so you just bring down, you just multiply these two, so this one you add, and then minus with the product, so this is the answer. Okay, so if the events are independent, it will be stated in the question, yeah, so you don't really have to worry. Okay, now let's see example 2. A, B, C are three events such that A and B are independent events. Okay, A and B are independent events. Okay, so here when it's stated A and B are independent, so we can straight away conclude that A intersect B equals PA times PB. Okay, where A and C are mutually exclusive. Okay, what does it mean by mutually exclusive? Okay, the word exclusive, okay, there are two different terms. There are two different terms, independent events and mutually exclusive. Okay, so now let's see. Okay, again, if events are independent, okay, so if events are independent, so we can conclude here PA times PB equals PA intersect B. Okay, but when it comes to mutually exclusive events, okay, what about mutually exclusive events? If two events are mutually exclusive, then the events cannot happen at the same time. Okay, which means the intersection of them will be zero. Okay, so as I've given you the example previously, right? For example, okay, probability of, okay, so let's say here in one classroom we have 7 boys and 8 girls, right? So probability of obtaining a boy is 7 over 15, and probability of, okay, getting a girl is 8 over 15. So let's say if we try to find what is the probability of the student chosen is boy and girl. So we know for sure the probability will be zero, right? Because there's no chance of you getting one student to be boy, both boy and girl, right? So we can say that these two events are mutually exclusive. Again, mutually exclusive events are the two events that cannot occur at the same time. Okay? So if you have the intersection to be zero, so we can conclude that the two events, G and B, are mutually exclusive events. Mutually exclusive events. Okay, so coming back to the example, okay, we have mutually exclusive events. So it's stated in the question that A and C are mutually exclusive. So we can say that, okay, we can conclude that A intersect C is equal to zero. Okay, so now, okay, we are given this. Given PA equals 0.4, PB equals 0.2, PC equals 0.3, and PB intersect C equals 0.1. Okay, find A union B. So again, in order to find union, so we use addition probability formula. So this is the addition probability formula. So addition, okay, so this is addition probability formula. Addition probability formula. Okay, so we have PA union B equals PA plus PB minus PA intersect B. Okay, now because we know that A and B are independent, so how do we obtain A intersect B? Okay, even though it's not given directly in the question, but we can obtain A intersect B from this. Because it's been declared in the question that A and B are independent, so probability of A intersect B will be probability of A multiplied by probability of B. So we substitute probability of A here, probability of B here, and this is probability of A multiplied by probability of B. So pressing calculator will give you this value. Okay, and then for the B part, how to find probability of C given B? So this is conditional probability, right? So this is conditional probability. So we cannot find the value directly, but we do have formula for it. So probability of C given B is equal to probability of C intersect B divided by probability of B. Okay, now because we are given B intersect C here, 0.1, so we substitute here, and probability of B also given 0.2, we substitute here. So this is the answer. Okay, and then next, okay, the question says, okay, find probability of C given A prime. So given A prime, so again, this is conditional probability. So in order to find conditional probability, we use the formula. So probability of C given A prime is equal to probability of C intersect A prime divided by probability of A prime. Okay, how do we obtain probability of C intersect A prime? Okay, so probability of C intersect A prime. Okay, how do we obtain this? Okay, because let's if we have, okay, A and C are mutually exclusive, okay, which means the intersection will be zero. Okay, if we try to draw Venn diagram, Okay, if you try to draw Venn diagram, if A and C are mutually exclusive, which means there's no intersection between them. So this is A, this is C. So when it comes to probability of C intersect A prime, so in C intersect A prime is basically PC. So this is basically PC. Because why? Because they are mutually exclusive, so there's no intersection. So which means probability of C intersect A prime will be simply equal to probability of C. So because we are given probability of C 0.3, so we substitute here. Okay, and then probability of A prime is simply complement event, right? So probability of A prime is simply 1 minus probability of A. So we have got probability of A 0.4, so it's 1 minus 0.4. So you will have the answer to be 0.5. Okay. Okay, so now let's see here. Okay, a mathematics puzzle is given to 3 students, Anan, Balkis and Chua. From the past experience, known that the probabilities Ahmad, Balkis and Chua will get the correct solutions are 0.65, 0.6 and 0.55 respectively. If 3 of them attempt to solve the puzzle without consulting each other, find the probability that the puzzle will be solved correctly by all of them. Okay, so now first we declare. So there are 3 students here, Anan, Balkis and Chua. Okay, so represented. Okay, we can use the 3 letters A, B, C to denote all the 3 students. Okay, so the events are A here, event that Anan answers correctly. B here, the event that Balkis answers correctly, and the C here, the event that Chua answers correctly. Okay, so we are given all the values here. Okay, so we write down the probability. Okay, so then find the probability that the puzzle will be solved correctly by all of them. Okay, because in this case we can say that how can we obtain this? Okay, how can we obtain this? In this case, we can say that probability of A intersect B intersect C is equal to probability of A times probability of B times probability of C, because they are independent. How can we do this? Because they are independent. Okay, because the event Anan answers correctly, it will not have an effect on the B and C. Okay, hold on. We have one question here. Okay, Bon tanya, Madam kenapa bukan 1 minus PA? Yang mana satu Bon maksudkan ni? Okay, ya, adakah yang ini? Adakah yang ini 1 minus PA? Kalau PA prime ni, this is actually 1 minus PA lah. Okay, because we know that A prime is complement event, right? So this is 1 minus PA lah. So that's why we have this one, 1 minus PA. Okay? Okay, Fizana kata Nan, nama kau, that is Anan lah. Okay, bukan Hanan. Alright, okay, so coming back to this example. Okay, because the events are independent, why is that? Example 2, question 3. Okay, so Bon masukkan example 2, question 3. So, betul lah tadi. Okay, 1 minus PA bukan 0.7 ke? Hold on, because PA kan 0.4 Bon. So PA is 0.4. So kalau 1 minus PA 0.6 lah. Kan? Okay, because PA is 0.4. So 1 minus 0.4 will give you 0.6 here. So 0.3 divided by 0.6 will give you 0.5. Okay, I hope it answers your question, Bon. Okay, sebab PA adalah 0.4 bukan 0.3. 0.3 tu yang ke atas tadi. Ini PC, probability of C. Okay, ni yang PC, 0.3. Okay, so okay, Bon kata 0.6. Betul lah tu, Bon, 0.6 lah. Okay, 0.6 maksud saya. Ya, betul, Bon. Memang 0.6. So, kalau PC is 0.3 divided by 0.6, so dapatlah 0.5 the answer. Okay. Alright. Okay. So coming back to this example. Okay, so because we can declare that the three events here are independent because the event of A will not have an effect on B because contohlah kalau Anan dapat betul ke salah ke dia tak ada effect pada Balkis. So the three events here are independent, like this one. Okay, so probability of A is 0.65, so we know that probability of A prime is 0.35. And ini pula, kalau probability of B is 0.6, so probability of B prime adalah complement event, so 0.4. So 0.45. So ABC ni dia adalah independent sebab tak kisahlah Anan betul ke, Balkis betul ke, dia tak mempengaruhi Chua. So we can say that ABC they are independent, so that's why we can come up with this formula. So probability of A intersect B intersect C is equal to probability of A multiplied by probability of B multiplied by probability of C. So this is the answer. And then next, find the probability that only one of them will get the correct solution. Bila one of them bermaksud sekiranya Anan dah betul, bermaksud Balkis salah, Chua salah. Or kalau Balkis pula yang betul, Anan salah, Chua salah. Or lastly, kalau Chua yang betul, Anan salah, Balkis salah lah. Because either one again, kalau Anan dah betul, Balkis dengan Chua salah. Kalau Balkis pula betul, Anan dengan Chua pula yang salah. Kalau Chua pula betul, Anan dan Balkis akan salah. Alright, so we use the prime to represent the complement events. So here, so A intersect B prime intersect C prime. So PA is 0.65 based on this. And then B prime 0.4 here. And then C prime 0.45. Next, Balkis pula betul. So probability of B 0.6. Bila Balkis betul, Anan akan jadi salah 0.35. And then Chua pun akan jadi salah 0.45. And next, bila Chua pula yang betul 0.55. So Anan akan jadi salah 0.35. And Balkis pula salah 0.4. So we just multiply them all and we add them, so we will have this answer. Alright, so now coming to the next one. So this is our last learning outcome for today. How to use Venn diagram, tree diagram and table of outcomes to solve probability problems. So whenever you come across topic 8 questions, so first thing first, you identify what method to apply, or what diagram can we use to picturize the situation. It's because to understand the situation better, we need a diagram. It's either Venn diagram, tree diagram, or table of outcomes, also known as contingency table. So now let's go through one by one method. So tree diagram. So tree diagram consists of a number of branches that illustrate all the possible outcomes of a sequence of experiments or events where each event can occur in a finite numbers of ways. The tree diagrams here tell you about the two events here. So let's say here you have the first event A. So this is the first event. So this is first event and this is second event. Second event. So what does this tell you? So this branch tells you the probability of A happens. While this branch actually tells you probability of B happens provided that A has happened, because you see the previous branch here is A, right? So the value here is basically the probability of B happens provided that the A here has already happened. So this is what the branch tells you about. And the same thing here also. If you have this B prime, so this branch tells you probability of B prime given that A has happened, because you see the previous branch is A, right? So that is the branch here, the representation of the branch. Let's say here, if you have the event B here, so this is the branch here tells you about the probability of B given that A prime has happened, because you see the previous event here is A, right? And then for this one, B prime, so this is the probability of B prime given that A prime has happened, because again, it depends on the previous branch. Saya bagi contoh lah. Saya bagi contoh. Let's declare two events. S is the event you study. And A is the event of getting A in PSPM. Contoh lah. Okay, contoh Okay, so untuk matriculation student, probability that matriculation student will study is 0.08. Okay, kenapa 0.8? Sebab ada juga yang tak study kan, betul tak? Okay, so maksudnya ni S prime yang tak study lah. Okay, so ada kebarangkalian pelajar study 0.8. Okay, and the probability that the students they do not study 0.2. Okay, ini adalah golongan yang main Mobile Legend, ini yang main PUBG, okay, yang main e-sport, okay, yang berkapel lah, okay, yang main-main dan sebagainya lah. 0.2 ni termasuk dalam ni, yang tak study tu lah. Okay, then this is the event. Okay, seramnya. Yeah, we talk about okay, we talk about real life situation lah. Okay, kita nak lah contoh dalam buku kan. Okay, kita ambil contoh yang real punya kan. Okay. Okay, Sam pun kata, nice one madam. Alright, okay, so contoh lah. Aduh sakitnya. Azari terasa ke? Tak apa, Azari dapat A. So Azari termasuk dalam golongan yang study tu lah. Don't worry Okay, so macam tu. Alright, so macam ni lah. Okay, probability of student yang study 0.8. Yang tak study pun ada 0.2. Okay, now sekiranya awak study, okay, apa kebarangkalian awak untuk dapat A? Okay, mestilah lagi tinggi kan? Sebab kalau study, okay, very highly, okay, very likely to happen lah. Okay, 0.99 lah. So sekiranya awak belajar, okay, is very highly very likely for you to get A. Tapi ada juga case di mana okay, dah usaha, dah belajar tapi tak dapat A. Okay, that's not your fault. Okay, but that is life actually. Sometimes kita dah study tapi tak dapat A. Itu pun berlaku. Okay, mungkin ada sebabnya ke, okay, we do not know, but yeah, again, that is life. Sometimes luck will be on your side, sometimes it won't. Okay, contohlah, okay, so this is what does this tell you? So 0.01 ni adalah probability awak tak dapat A diberi bahawa awak dah belajar. Provided that you already studied but you didn't get A. So that is the probability lah. So this is the branch, what the branch tells you about. Manakala 0.99 ni pula, this is the probability of you getting A provided that you study. Provided that you have already studied, okay, and you get A. So that is very high, okay. Kalau dah study dapat A, itu sangat tinggi. Okay. Then second case, okay, second branch pula. Okay, ini tak study tapi dia dapat A. Okay, biasalah sometimes that is life, okay, because yang tak study ni walaupun dia tak study tapi dia gifted kan, otak dia bukan macam otak orang lain lah. Okay, tapi ada juga dia dapat A, mungkin nasib menyebelahi dia, okay. So dia dapatlah A 0.5. Okay. Okay, dan tak ada juga dia tak dapat A lah. So ataupun saya kecilkan kat sini lah, tak ramai sebenarnya pelajar yang main-main tapi dapat A ni. Okay, 0.2 lah kat sini ataupun 0.005 lah. Okay, ataupun okay 0.05 lah. 0.05 tu macam contoh lah. Okay, 0.05. Macam Phil katakan, untunglah lahir-lahir pandai. Ada student yang macam ni, dia gifted, okay, dia tidur dalam kelas ke, dia main ke, tapi dia still dapat A. Okay, ini very rare lah, sangat-sangat rare, susah nak jumpa. Okay, that's why probability is very low. So macam ni lah. So untuk 0.05 ni, okay, kebarangkalian dia dapat A tapi dia tak study. Okay, yang 0.95 ni ramai. Okay, so kebarangkalian dia tak dapat A dan dia, okay, disebabkan dia tak study. Okay, ini biasalah. Ini pun biasa. Ini biasanya okay, golongan-golongan yang late bloomer lah, I would say late bloomer. Sebab dia belum insaf lagi, dia tak, kesedaran tu tak dapat lagi. Okay, late bloomer. Okay, dia tak study, dia main-main dan dia tak dapat A. So that is very likely to happen lah. Okay, so that is the probability lah. Okay, so you can see here, this is what the values tell you about. Okay, so 0.05 here is the value of probability of you getting A provided that you didn't study, and here 0.95 ni probability of you didn't get A. Okay, probability of you not getting A given that you didn't study. Okay, so event yang dah berlaku ni akan kat depan. So event yang first ni, so this is the first event, and then the second event will come afterwards. So which means here we can say that the A here, the A event here will actually depend on the S event. So we can say that okay, A and S, they are dependent on each other lah. Okay, A and S, they are dependent on each other. Okay, because the event of the event of A is dependent on S. Okay, so this is where we can apply the tree diagram lah. Okay, if the second event dependent on the first event, okay, so we can use tree diagram. Okay. Ya, okay, Sophie ada tanya kat sini, macam mana kalau dia study? Okay, macam mana kalau dia study tapi tak dapat A? So kalau dia study dia tak dapat A, dia akan termasuk dalam ni lah. Dia study tapi dia tak dapat A, yang inilah. Okay, so yang ini termasuk dalam golongan yang nasib ni tak menyebelahi dia. Tapi tak apa, because again it's the effort that counts, not the outcome. Okay, kadang-kala kan Tuhan tak tengok awak punya outcome, Tuhan tengok usaha awak. Okay, your outcome, what have you done. Kalau kita tengok based on effort lah. So it's the effort that counts. Okay, so yang penting usaha tu. Okay, kita nak tengok usaha. Okay, kenalah rajin buat tutorial, buat pasir kan. Okay, so itulah tazkirah hari Jumaat Okay, now let's continue. Example 1. Okay, example 1. Okay, let me hide first this comment. Okay, okay, Zafran dah terbatuk di sini. Okay, so now let's see. Okay, example 1. The probability that Sophia is late for college on any day is 0.15 and is independent of whether she was late on the previous day. So that means, okay, the event of getting late on the second day, it will not, the event of getting late on the first day will not have an effect on getting late on the second day lah. So that is what it meant here, independent. Maksudnya event yang berlaku untuk first day tu, okay, it doesn't affect the second day. So that means the probability is going to be the same lah. Okay, so which means probability of getting late on the first day will be the same of probability of getting late on the second day. Okay, so that is what it meant here, independent. So dia tak okay, the probability of getting late on second day here, it is not dependent on the probability of the getting late on the first day. So that's why the value is equal. Okay, so find the probability that she is late on Monday and Tuesday. So she is late on Monday and Tuesday. So I use, okay, so this is the event late. So I use L1 to represent getting late on first day, which is Monday. And then L2 here, getting late on Tuesday or the second day. So if the question asks for, okay, find the probability that she is late on Monday and Tuesday. So now we are looking for L1 intersect L2. So how to get L1 intersect L2? So we just multiply the values on these two branches. Okay, why is that? Because, okay, again, as I told you just now, so this is the event, okay, of 0.5 here is probability L2 given that L1, right? Okay, so if we use the conditional probability formula just now, probability of L2 given L1 is equal to probability of L2 intersect L1 divided by probability of L1, right? Okay, so because this one is 0.15, okay, and then divided by probability of L2 intersect L1 divided by probability of L1 here is also 0.15. So how to get actually probability of L1 intersect L2? So it's about the product of these two. So we just multiply the two branches. So again, okay, whenever you use a tree diagram and you need to find the probability of intersection, so you just look for the probabilities and you just multiply them. So you will get the probability of intersection. So probability, okay, so we have 0.15 multiplied by 0.15. So this is the answer. Okay. Alright. So okay, let's say if I use the previous example just now. Contoh lah, kalau saya guna example yang ini tadi. So contoh, find the probability of, okay, the student study and get A. Okay, and ni bermaksud, okay, so how to get here? So S intersect A. So basically you have this branch for S and this branch for A, right? Okay, so you just multiply these two. So you will get the probability of S intersect A lah. So 0.8 times 0.99. So you will get the answer. Okay. Why? Because actually 0.99 is probability of A given S, while this is probability of S. Okay, so again, if we write the conditional probability just now, okay, probability of A given S is equal to probability of A intersect S over PS, right? Okay, so A given S is this 0.99. And then A intersect S is unknown. We do not know, okay, because we cannot tell, okay, we cannot get the value directly from tree diagram, because the tree diagram doesn't give us the intersection between the two events. Okay, unlike the Venn diagram, yeah, we can get the intersection, but when it comes to tree diagram, we cannot get the intersection between two events directly from the tree diagram. So now PS is 0.8. So in order to get the intersection, so you just cross multiply, so you will get 0.8 times 0.99. So again, okay, whenever you use tree diagram and you need to find intersection between two events, so basically you just multiply the probabilities. Okay, you just multiply the probabilities on the two branches lah. Okay, so that is why, okay, that is how we apply. Okay, then, okay, next, B. Find the probability that she arrives on time on one of these days. One of these days means it's either she arrives late, okay, or she arrives on time on Monday, or on time on, okay, on Tuesday. So here again on time on Monday, so this one on time on Tuesday. Okay, I use the O to represent the event on time. Okay, so O1 intersect L2. So O1 intersect L2 means O1 is here, intersect L2 here. So you will have 0.85 times 0.15 here. And then L1 intersect O2. So L1 here, 0.15 intersect L2. Sorry, intersect O2. So O2 is here 0.85. So 0.15 times 0.85. So this is what we have. And then we will get the value here. Okay, 0.255. Alright, okay, then next. Okay, the question says, find the probability that she arrives on time on Tuesday, knowing that, okay, knowing that means this event has already happened. She was late on Monday. So she was late on Monday means L1. So she arrives on time on Tuesday. So arrive on time on Tuesday means O2. So the question now says, find probability of O2 given that L2. Sorry, L1. Okay, because she was late on Monday. So Monday means L1. So how to find O2 given L1? So here I have written down here. So O2 given L1. Okay, so O2 given L1, we can use formula. So O2 intersect L1 divided by PL1. So O2 intersect L1. Okay, erase first. Okay, O2 intersect L1. So where is the O2 intersect L1? Is this O2 intersect L1? So 0.85 times 0.15 and then divided by PL1. So this is probability of L1, 0.15. So you will get 0.85. Or, okay, alternatively, we can get the value directly from the tree diagram, right? Because, okay, given that, okay, she was late on Monday, so this, what is the probability that she is on time on Tuesday? So on time on Tuesday, given that she is late, so this is basically the answer, right? So this is what it tells you. So this is 0.85, which means she is on time. Okay, given that she is late on Monday, this is the probability that she is on time on this day. So, okay, you can simply refer the table. Okay, tree diagram. So you just refer tree diagram. Okay, we can get the value directly. So, okay, probability of O2 given L1 can be obtained directly from tree diagram, which is 0.85. This is it. Okay, probability of O2 given that L1. Okay, because you can see the previous branch is L1. So this is the event of O2 given that L1. Okay. Alright. So now Venn diagram. Okay. So Venn diagram we have used a lot, right, in previous Examples. So Venn diagram uses overlapping circles or other shapes to illustrate the logical relationship between two or more sets of items. Often they serve to graphically organize things, highlighting how the items are similar and different. So Venn diagrams, also called set diagrams or logic diagrams, are widely used in mathematics, statistics, logic, teaching, linguistics, computer science, and business. Many people first encounter them in school as they study maths or logic, since Venn diagrams become part of new math curricula in 1960s. So these may be simple diagrams involving two or three sets of few elements, or they may become quite sophisticated, including 3D representations as they progress to 6 or 7 sets and beyond. Okay, but in our syllabus, we don't deal with 6 or 7 sets. Okay, the maximum is 3 only. So you don't really have to worry. Okay, so this is what the Venn diagram tells you about. So if you have, okay, so this is the event A. So this is the event B. So this is where the region A intersect B prime. So this is the region A prime intersect B, and this is the region A intersect B. Okay, and this is the region where A union B prime. Okay. So basically, we can use the Venn diagram to prove the De Morgan's rule. So we have De Morgan's rule. Okay, let's recall De Morgan's rule. If you have probability of A prime union B prime, so you can take out the prime. Okay, we can bring the prime out, provided that, okay, we have to change the sign here, so it will become A intersect B prime. Okay, and then next, if you have probability of A prime intersect B prime, so we can take the prime out. So again, provided that, so the prime out, so we can take the prime out, provided that the sign of intersection here, we change it to union. Okay, so again, we can prove using Venn diagram. Okay, so the De Morgan's rule can be proven using Venn diagram, and same thing applied with the other formula. Okay, so other formula, so where we have, okay, so other formula we have, okay, probability of A, okay, intersect B prime. So how can we get A intersect B prime? This region, right? So it's simply PA minus PA intersect B. Okay? Or if you have probability of A prime intersect B, so this is basically A prime intersect B, right? So you can get this by simply subtracting PB minus PA intersect B. Okay, so again, we can obtain this, okay, or we can prove this other formula also using Venn diagram. So actually, Venn diagram, it helps a lot. Okay, but it depends on the question that we have. Sometimes tree diagram will be helpful. Sometimes contingency table is better to be used, and sometimes Venn diagram. Okay. So now let's see here. Okay, example 2. There are 60 students in certain college. 27 of them are taking maths, 20 are taking biology, and 22 taking neither maths nor biology. Okay, so the 22 here, not taking maths, not taking biology. Okay, so how do we express how do we put all the values here into the table, into the Venn diagram. Okay, so first thing first, we know that this is an S. There are 60 students altogether. Okay, so 27 taking maths. Okay, so 20 students taking maths. Okay, and then 20 taking biology. So 20 taking biology. Okay, then 22 taking neither. Neither means outside. So neither means not maths, not bio, so prime. Okay, because actually it comes from here. Not maths. Okay. How do we express 22? 22 here, not maths, and not bio. So we can use the De Morgan's rule, right? We take out the prime and the intersection here change to union lah. So this is 22. Okay, so find the probability. Okay, the student takes both. Okay, first, again, okay, whenever we need to draw Venn diagram, okay, the first thing first we need to insert is the intersection. But since we do not know the intersection, okay, because it's not given, right? It's not given. Okay, the number of students taking both biology and maths not given in the question. this is unknown. So we let this to be X. Okay, because it's not given, so we let this to be X. So this is what we insert first, X. Okay, now, okay, 27, you cannot put 27 here because why? The number of students taking maths here, 27. Out of this 27, there are X students who take both maths and biology. So these 27 are including those students who are taking both. So we cannot simply put 27 here because if you put 27, then X here, that means the value will be greater than 27 lah, okay? And we don't want that to happen because only 27 students are taking maths, including those who take both, okay? So that is why, okay, that is why here we put 27 minus X, okay? And then here, because 20 taking bio, and again, out of these 20, there are X students taking both biology and maths. Okay, so among these 20, ada X yang ambil both. Okay, so here you put 20 minus X. Okay, then find the probability that a randomly selected student takes both. Okay, now we are looking for the X value. Okay, and because we know total of students is 60, right? Okay, so we know that the sum of this, which means this one, okay, the sum of this 27 minus X, 27 minus X plus 20 minus X plus 22 will give you 60. So you just find the sum of 27 minus X plus, okay, the intersection X plus 20 minus X plus 22 equals 60. So, and you just write down the X as a subject. So X equals 9. So now we know there are 9 students taking both mathematics and biology. Okay, so find the probability. So probability means it's 9 over 60, so it's 3 over 20. Okay, now find the probability that a randomly selected student takes mathematics only. So mathematics only means, okay, without the bio lah. Okay, mathematics only means this lah, 27 minus X. So 27 minus 9 will give you 18. 18 over 60 is 3 over 10. Okay, now, okay, soalan tanya, a student is selected at random. Determine whether the event taking maths is statistically independent of the event taking bio. So, okay, just now we discussed, right, the independent events. Okay, so if A and B are independent, so we can say that probability of A intersect B is equal to probability of A multiplied by probability of B. Okay, now this is general statement. Okay, now, okay, we change the A and B to be M and B. So if I change this to be M and B, so if M and B are independent, so thus probability of M intersect B is equal to probability of M multiplied by probability of B. So now first, let us check probability of M intersect B. Okay, M intersect B is this one, right? We have obtained earlier, 3 over 20. Okay, done. Okay, now let's check the right hand side. Okay, so this is the right hand side. Okay, probability of M multiplied by probability of B. So probability of M, okay, because we are given in the question, right, there are 27 taking maths. So probability of M is 27 over 60, which is 9 over 20. And then probability of B, there are 20 taking biology. So 20 taking biology, 20 over 60 is 1 over 3. So we multiply 9 over 20 and 1 over 3. So we will obtain 3 over 20. So this is 3 over 20 on the right hand side. And you see here also on the left hand side, this is also 3 over 20. So you can see here in terms of values, they are equal. Okay, how do we obtain this 3 over 20 just now? From the Venn diagram here, X here. This is what we get. Okay, so this is the M intersect B from the Venn diagram, while this is PM multiplied by PB from the, okay, product here. So we compare in terms of values, they are equal. So we can say that those two events are independent. Okay, sometimes the question will declare if the events are independent, or sometimes the student will ask you to determine whether they are independent or not. So it's your job to determine, okay, whether they are independent or not. Okay, and lastly, let's see here. Okay, so this would be our last example for today, table of outcomes. All right. Okay, so what is table of outcomes? So table of outcomes is a table where the first row and first column represent the possible outcomes in each event. Okay, so we use table of outcomes if we do have intersection of the two events or the intersection between the complement events. Okay. Okay, so now let's see here, example 3. Okay, the following table shows the number of graduates from 3 local universities in 3 major fields, namely maths, statistics, and computer science. Some of them were selected by a sponsor to further their studies. Okay, so now calculate the calculate the probability that a graduate selected is from UKM. Okay, so now after we are given the table. Okay, so we are given the table and I'll put some letters to denote the events. Yeah? So in this case, you see, mathematics, for the event mathematics, I use letter M. For statistics, I use letter P. Okay, why didn't I use S? Because again, S usually being used for sample space. So that's why we try to avoid using capital S. Yeah? Okay, statistics here, I use T. And then computer science, I use letter C. Okay, while the UKM here, I use K. UPM here, I use P. And the USM here, I use U. Okay, again, why didn't I choose S? Because S is commonly used for sample space. So again, we need to avoid using the S. Okay, where this is actually the NS. No? Okay, so again, we reserve the S letter for sample space. Okay, so that's why we avoid using letter S for any event. Okay, so now calculate probability that a graduate selected is from UKM. So UKM is K, right? So the question asks for PK. Okay, so we total up all of the students. Okay, regardless of their major or regardless of their course here, mathematics, statistics, or computer science, so we just total up them. So you can see here the number of UKM students are 160 students. Okay, so 80 plus 50 plus 30 is 160 divided by 450, and we will get this to be the probability. Okay, so that is probability of K. Okay, now what is the probability that a statistics graduate selected is from UPM? Okay, now you need to read again the question. What is the probability that a statistics graduate? Now in this case, we already know that the student is a statistics graduate. Okay, so this event has happened. Has happened. Okay, so since the event has happened, so now we just need to find the probability that the student is from UPM. So okay, the UPM here we use letter P, right? So we need to find probability of P given T. So we use formula. So probability of P given T is equal to probability of P intersect T divided by probability of T. So P intersect T is this, P intersect T. So this is where it's located, the intersection. 65 over 450 divided by, probability of T. Where can we obtain probability of T? So this is where the event T, right? So this is where the event T is located. So we just find the sum. So this is probability of T, 185 over 450. And then you just press calculator, you will get 13 over 37. Okay, now for the C part. One graduate is selected from each university. Okay, so please bear in mind this is actually application of permutation and combination. Yeah, okay, where we apply the C here. Okay, so one graduate is selected from each university. So in this case, please bear in mind our NS is not 450 anymore. Okay, because we select one graduate from each university. So from this university, we select one. From this, we select one. From this, we select one. Okay, and from this also, we select one. So our NS is not 450 anymore. So it's this. Okay, so one graduate is selected from each university. Okay, so the NS is 160 C1 times 155 C1 times 135 C1. So this is our NS. Okay, now find the probability for the 3 selected graduates to be all majoring in mathematics. Okay, so for the 1 Roman, It's here. Okay, what is the probability that all the three graduates are majoring in mathematics? So now mathematics, we refer this one. Okay, so we focus on this. So that means because one graduate is selected from each, right? So from this 80 we select one. We choose one, and out of this 50 we choose one, and out of this 40 also we choose one. So 80 C1 times 50 C1 times 40 C1 is equal to 160,000. So in order to find the probability, so this is basically the number of ways. This is not the probability yet. So in order to find the probability, is the NM over NS. So 160,000 divided by this will give you this answer. Okay. And now, for the second Roman, all from the same major, same field of major. So which means all the three graduates, same major. So that means all mathematics graduates, or all statistics graduates, or all computer science graduates. So in this case, same field means again 160 means all maths, and this one all statistics. So you can see here, out of this 50 we choose one, 65 we choose one, 70 we choose one. So this is how we obtain. And then next, out of for computer science, out of 30 we choose one, 40 we choose one, 25 we choose one. So this is for computer science. And this is for maths. For stats. While this one is for maths. This one is for maths. Because we have obtained earlier, right, the probabilities. So we just bring it down. We just bring it down, 160,000 number of ways. So we add this with this and this, so you will get this to be the answer, but this is the number of ways. So in order to find probability, again, by recalling the concept of probability, so probability of A is basically the number of outcomes in event A divided by total number of outcomes, right? So in order to find probability of same field, so this value we divide by this value, so you will get this answer. So basically, how do we obtain this answer? By dividing 417,500 with 334,8,000. So you will get this answer. So basically, that is how to answer this kind of question. So basically, again, as a wrap up, so I will show you the summary. So we are done with all the examples. Now let's see the summary. Table of outcome. So basically these are all about topic 8. So basically we have accomplished all learning outcomes. So we had discussed the all the terms. But you don't really have to worry lah. This one is just for you to understand the terms. We do have one question here. Madam nak tengok yang bawah tu boleh? Yang bawah tu yang ini ke Mai? Ini ke? Yang bukan overweight tetapi ada tertinggi. Jadi bila ada situasi yang hilang ni, perlu disarankan. So total number of the professor adalah 100. So again, this one, how do we obtain this answer? Based on this concept, probability of event A is basically number of outcomes in the event divided by total number of outcomes in sample space. Okay, so just now we look for the number of outcomes for the candidates or for the graduates to be chosen, okay, all from the same field of major. So which means all are mathematics graduates, or all statistics graduates, are all, okay, or all are computer science graduates. Okay, so that is how we find the number of ways lah. Okay, because maths we have obtained earlier 160,000. So that is how we get the number of ways, and then we just divide by this and s. Okay, so we will get this answer 835 divided by 6696. Okay, alright, my done. Okay. Okay, my pleasure. Alright, so now let's wrap up this topic summary. Okay, so I hope you can make full use of the summary, okay, to help you with the problems in tutorial book. Okay, so these are basically the terms that you need to understand. Okay, and these are the basic laws. All right, so this will be given in exam, this will be given in exam, this one also, so you don't really have to worry, you don't really have to memorize, you just need to understand. Okay, so again, probabilities, the value must be between 0 and 1. You cannot have probability to be negative, or you cannot have probability to be more than 1. Okay, and then sum is 1, and then this is complement rule. Okay, then this is addition rule. Okay, make sure you know the name. Okay, this is the name, okay, of the formula. It's addition rule. Okay, and this is conditional probability formula. Okay, and we can modify the formula lah. Let's say if you have B here to be at the front, so you can swap the places lah. Okay, and again, okay, probability of A given B. So I put a remark here. Okay, so as what Zilong asked just now, probability of A given B is not equal to probability of B given A. Okay, hold on. Prime over B W prime. Okay, so H prime if intersect W prime. So apa yang kita nak ambil kat sini, so tengoklah kita tengok berapa. Okay, awak tengok kat sini 66 tau. Sebenarnya kita boleh tulis 66 kat sini tau. Awak tengok H prime intersect W prime. Kat mana H prime? H prime intersect W prime. Prime intersect W. Probably bermaksud kena ada ke barang kalian bermaksud nilainya ada yang tenang terus. Hold on guys, I'm having trouble with think the internet connection is not that good here. Okay, so never mind. We will wrap up this. Okay, so you just refer the summary. Okay, you just refer the summary of topic 8. Okay, and then from there you try to understand the examples that we had discussed earlier. Okay, and and you try to do the tutorial problems. Okay, questions. Okay, and so do you have any particular problem, or do you have any question to ask? Okay. No, alright, so I think that is all for today. Okay, so I hope that you can start doing tutorial questions. Okay, so we will continue discussing this topic in class. Alright, so any problems you may ask me in the Telegram group or we will discuss in the classroom. Okay, guys, so that is all for today. Thank you for your attention. Thank you for your presence. Okay, so I will stop here. Assalamualaikum warahmatullahi wabarakatuh and have a nice day, everyone. My pleasure, Fir.